Hello and welcome everyone to this webinar today. We will be talking about precast detailing in impact. This will be a part 1 in a 3-part series of webinars. Today we will focus on beams, columns and hollow cores. And as a matter of introduction, since this is my first webinar at TrueSoft, I am Michał Sikora. You may know me from some tips of the week for the last couple of months that have been uploaded. I'm a business development manager at TrueSoft. And I'm based off in Kraków in Poland. All right, so without further ado, let's move further. So today we will focus, as mentioned before, on beams, columns and hollow cores. We will be modeling beams and columns and hollow cores as mentioned. We will also design a corbel with impact and apply that to our column element, as well as we will be deciding on the reinforcement in that corbel. We will be inserting some casting materials either in the corbels or in some other elements in the presentation today. I'll also demonstrate to you rebar templates and functionality of those for the particular structural elements that we'll be discussing. We will save the elements to impact database. After saving those elements to the database, we will be able to preview those in Impact Project Manager. And of course, we will be generating shop drawings as can be seen in the preview on the screen here. Okay, so let's move out to AutoCAD actually. I have a model prepped with a grid for us to follow in this particular session. So we can immediately start. If we have a grid, then we can start drafting elements. Well, we could without even a grid, but grid helps. So let's start with columns. I'm going to select the column tool and I will be able to now select the dimensions of a particular element, right? So I will choose a 50 by 50 column. Let me just find that. And immediately in the preview, you will be able to see some reinforcement applied to this particular column. We can accept that. That's one of the templates that's already predefined in the standard that I have here. We can add to that standard. So for this shape, 50 by 50 centimeters of a column, we can add different types of reinforcement or other different templates of reinforcement, but we'll focus on that a little bit later. So I'll first accept what we have here. So just this one. And I'll show you later how to modify that, or rather how to add to the standard, to the definition of the columns that we have, so we can use that further down the line in the design. Next here, after choosing the type of column that we want, which is 50 by 50, we actually need to specify how tall we need that column to be. By default, typically column is selected to be 1-story height. So if our floor is 3 meters tall, then that's basically, as is the case in this particular example, 3000 millimeters is the default column height. But I want this particular column to go to the top of the second floor as well, so I will increase that to 6000. Yes, that's nice and even value, but I want that to be easy for us in this presentation, so 6 meters it is. Next is a matter of selecting of casted materials lifts for our element. So that's the either by section or by user, so we can define that either by ourselves what type of lift that is. In this case it's by section, so this particular section has defined some type of lift here. It's not selectable if I go by user. This is selectable to a different type of lift, but I'm just going to leave it by section. All right, and side, so basically how the column is rotated. And the other tabs that we have available before placement is top. So basically the shape of the top of the column. If you want to have an angle and slope to the top of the column for maybe architectural reasons or structural reasons, we can do that. Or we can automatically apply a corbel to that as well. But let's leave it simple for now. Next section, something that might have come up in tips of the week, but we can locally change the section of the column, so make it either thicker or thinner, or different shape entirely in a particular, for example, for a particular height, maybe on the bottom of the column. And model specifies the assignment of that column. If it's assigned to the first building, for example, first floor, or the phase, what's the presentation of that column, if it's solid or wireframe, if we need to lock the elevation. This is a function that I'll be using later for other elements, but we'll see that. And the placement of the column, or the insertion of that column, and in this case it will be by the center, as it will be very easy to just click on the intersections of the grid. So let me do that for us. Let's place the columns. And for this particular scenario, I'll be placing my grids, my columns on grids in this line here up to 6 and C's. But so let's do that. I'm just going to be accepting the rotation of the columns, placing them one by one. Very simple and very quick as well. Not much to it, and that's done. I'll just press space to accept the selection. We can of course rotate the model now to 3D, see how it looks like. So we have our 6 meter tall columns, and I can just, go back to the top view for us. But I'm not done yet with it. What I want to do is I actually want to add another column in this area. So on the axis B, I want to add shorter columns of a different shape. So let's go 50 by 40, so more square-ish, other rectangular-ish column. And for this one, I actually want to be just 1 story high. So let me do that. And the rotation, I want it going this way, right? And same thing here, even like that. I could of course change the rotation in the insertion point, but we can leave it like this for now. And again, we can rotate the model so you can see they are in fact shorter. So as you may have noticed, we are working on a basically floor plan basis from our model, and we create 3D objects in that floor plan. All right. So with this, we are now done. I'm just going to have a look at my cheat sheet on the right, just to get know the order of operations that I've planned for today. So with that said, we're done with the column placement. I'm happy with that. We still have plenty of room to expand upon that structure on further webinars, but columns are for now done, right? What we can do now is we can play around with the reinforcement of those columns. So let's go back and open up one of the columns and go back to the properties, just to remind ourselves. There's a reinforcement, there's a template. This template gives us some insight into how the reinforcement will look like. We won't be able to see 3-dimensionally how that reinforcement will look like, as this is something that we, in the Impact for AutoCAD, we do at the drawing level. So we can apply a template, but then the reinforcement we will see only on the drawing. So not a problem there. But in order to modify the rebar template for the columns, we actually have to go to the definition of the columns. I have to one definition in the project itself. Let me import the definition of the columns as well, the 50 by 50. Oops, I didn't import that. You always need to import and accept that. So we have our column here, and let me edit that. And in the edit, I can go to the reinforcement tab, and we see those 2 templates that I had for selection before. I can click on those and see if there are any changes. There are some. Some only have additional reinforcement at the bottom of the column. Some don't have additional. This one, for example, has additional strengthening reinforcement for shear for the second bottom. section. But how can we add a reinforcement template to a section? It's easy. We just right click in the template section, create a new, and for example, whatever we can type in whatever we want, whatever makes it easy for us to understand what that is. So say let's change the way that the description is here for something like diameter 6 at 300. So say and maybe main rebar, like let's go maybe 6 times 20, 6 times 20 plus 6 diameters at 300. Or maybe let's go 6, maybe 8, so more rebar, so you can see a bit more reinforcement in the section. Well, let's accept that. And another window immediately pops up for me to specify like either the number of straight bars or the stirrups. So the first one is stirrups. So I can utilize all the tools I have here. First, the shape code. So is that like an L bar, or other L-shaped bar, or a different type of bar? Let's go maybe with a 51. Bar mark none. We can have a new bar mark 51. And now we can specify that new type of bar mark like so. And quality, we can make that quality of still B for now. Jig radius, so basically we specify the dimension, so the basically the diameter of the bar for stirrups. Let's leave it at 6 because I defined that as 6. Jig radius, that's basically a bend radius for the bar. Some remarks for that, those are not very important. The way this shape code works, we have basically the A and B dimensions, so best to just show it. Let's go 400. All right, and so this is our A dimension, and B dimension will be, for example, the height, 400. And our C and D dimensions are basically the bent legs that we have in this shape code. So let's make those more reasonable, 100 and 100. Now with the scale slightly better visible, you can clearly see the bends in the corners of that. And that's enough for this. So that's the shape code that we have. 400 by 400, the column is 500 by 500, gives us 50 mil cover each side. So let's accept that and let's use that. And immediately you can see the bar has been placed on that preview. So it's just a matter of actually placing it in position. So let's see 0, 0. Let's go for 50. That seems to be perfectly in the middle. This one seems kind of off. So maybe 350. Yes, this works out for the placement. Maybe I chose it wrong, and yeah, that's the insertion point on this leg. So that's how we can place the bar mark. Now, location from top and location from bottom. Basically, as you can see, that's how far from the top and bottom actually the B-bar spacing starts. So let's go 250 and 250, or maybe 300. And 300 here, and 300 spacing for our bars as well. And location top to bottom, we can also specify an area of denser reinforcement. So this is number of bundles in second, distance first to second. Basically, here we can specify if we need some additional shear reinforcement for top and bottom of the column. So we can do that. Like we can go 150 here, 150 here, 150 here, so it will work out nicely with the spacing. And that's both for top and bottom when I'm setting that up. And let's maybe make 5 and 5. Yeah, 5 and 5 bars. We'll see how that looks on the drawings. If it needs corrections, then we can of course correct that later. Now, let's go to straight bars. And for straight bars, we need to assign the cover. As mentioned, I have 50 mil cover for the stirrup. So let's make that 60. Yep, that works out for those bars. And let's go bar size 20. Okay. Now, corner bars is just 1 bars in corners, but then we can specify front and back number of bars in front and back, so that can be 2. And we can also specify number of bars left and right. So let's make that 2 as well. Okay, so that's a bit overboard. Let's go maybe 1 and maybe 1 here, 1 here as well. Okay, so that gives us 8 bars in total for this, and we can accept that. And of course, you can see that in the preview. Okay. All right. And we can specify which template is the default for our bars. We can, of course, not of course, but we can also specify the exact positions of the bars if needed. So you can see the bars are highlighted. We can change the position if that would be needed for a particular case. Right. So that's how we can do that. So let's accept that, and let's accept that that template. What I'll do now is I'm going to select the columns in question, so those 50 by 50. I can either go back to plan and click on edit columns, or I can just double click after selecting those and get back to that. And you can immediately see that we have our preview. It will take a little bit to load on that preview of the template of reinforcement that we have. Just maybe switch back and forth. Yep, and that loaded. And that's it. I can save that, accept that, update lifts. And now this reinforcement template has been applied to our columns. So now we are kind of, but not yet done with the columns. We'll still be adding corbels, but corbels, it's easier to have the beams first. So let's do that. Let's go to the beam tool. Let's draw a beam, and we'll just use a typical rectangular beam, and that's going to be size 18 by 58. So a big beam like this, and we're going to use the standard reinforcement template that we have for this particular beam. We can also specify lifts here as well if we need to change something at the ends of the beams, which we will, but that will do after we're done with the corbels. We can again modify the section at a specified distance, for example. So if we need to make a beam bigger or smaller an area, we can do that, as was with the case with the columns. And the last one is the placement. Now this one I will use because I want the tops of my beams to be at the elevation of the top of the column. So I can do that very quickly by changing the placement to top center instead of bottom center. So as you can see in the preview, this is my alignment point, or rather my insertion point. I want to lock the elevation. So because we are working in 3D model, it's easier to lock the elevation to a specific point if we're placing horizontal elements, so we know we are keeping that elevation. Sometimes we can snap with the AutoCAD to some point that we don't really mean to do that, and then it will be at an angle or placed very weirdly or not exactly how we want to do that. So worthwhile to do that. Let's go to 6000, and that should be it for the placement of those columns. I don't really want to modify anything else in this particular scenario. So I want to do that. I want to specify the first point here. I also want to apply offsets. So they're not exactly flush with the columns, because that's offset left and now offset right. And as you can see, we are now offset with the beams. Because leaving those elements flush, not exactly perfect. Simply put, it might be hard to place those elements on site if they're flush. Or we might crack some concrete or do something we don't really want to do. That's done, and just last one on this side of the building. Place it Did I place that correctly? I think I did not. So I'll just go back to that and replace that later. I think I snapped incorrectly on that one. Not a problem. Non-stressed beam again. Same thing. Yes. 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 And yes. And the last one here. It's good. What I'm going to do is I'm going to do such a little thing because I'm pretty sure I missed that element. Of course, if I want to snap those elements now. Oh, my column is off. I'll need to correct that as well. Okay. Yeah, that's a mistake. Let's delete this and let me delete this column as well. Now let's place that column. Yeah, now let's go the 50-50. Let's go 6,000. Yep, and apologies for that. I want everything to be aligned nicely. Yep, that's my column. For some reason it's rotated. That's probably because I used a different column. Okay. It might be easier to just do this. And yep, easiest solutions are the easiest. Yep. And again, just verify that we have locked. Yeah, we've locked the elevation. And now yep, that's done. Let me verify if the column didn't run off. Everything looks good. Yep, so we have our beam. It's exactly as I wanted it. Let's go to the front view. So my top is flush like that. But we are not done. Oopsie, let's turn that off. Let's turn off the properties, don't need those. Let's go to the top view. Okay, now what I want to do is I also want to place some beams here. Those will be my supports for hollow cores later. So let us do that, right? This time I'm going to go not this one, but latch the beam. Yes, that's this one. And let's place this one. Nope, those are the ones that I want to use. Okay, different thing now. Let me verify the placement. The top I want to have at not 6,000 but 3,000. Top center, that should be good. Ends, fine. That should be good, and we are okay to go. Now, one thing that's important is the direction in which we draw the element. So I want to go from bottom to top, so my my ledge will be on the right side, which you will see right now. And offset is applied. I can see that, which is good. Yep, that's good. Same thing here. Let's apply that. Yep. That's clicked. Now I will go the other way around. So from top to bottom for the left side. Yep. And like so. Okay. So if we rotate the model, now we have ledge beams, as you can see, solid geometry here. And yeah, that's how we can place those elements. Basically, we're pretty much done almost with our columns and beams. One more thing that we need to do. We actually need to create corbels. So this will be easy. Let me go to top view again. This will be very easy. There's a couple of ways we can do corbels. We can either draw a corbel by selecting a column and deciding if you want like a single corbel, double-sided corbel, and do all the settings manually for everything. Or we can utilize the draw corbel from element, which will make impact look if there are any beams next to your columns. Right, I'm just going to do that, select all the elements, and it will apply the corbel geometry automatically wherever they are needed for our columns. Okay, so there's a bunch of settings we can do. There's a template predefined, for example, in my standard, which gives me some basic dimensions, but I can of course modify those if I want support to be bigger than 250 mil, the height of that, the H2, so height of that basically corbel. If I want that to be 250, then yeah, it can be the overall height, like half a meter. I can change that now. I'll leave it as is. It's good enough for a demonstration. One important thing, you can specify if you want to have a fixed width of a corbel, or if you want to have, or you have, for example, a width of the corbel to be the width of the element. So in this case, a column, right? I'll leave it as by element. I personally preferred it that way. Of course, if you need thinner corbels for maybe like thinner elements, or maybe you want the corbel to be offset by to one side, of course you can do that. Important thing, you can also specify cast-in materials. So for your lifters, for your corbels, you can specify that in the cast-in material section. All right, so let me just accept that. I want to now specify a gap between the corbel and the element. So there is some, for example, like a rubber bearing or whatever for the columns, or just some leeway tolerance available between the corbel and the beam. I'll just leave it at 10 mil. And it's done. As you can see, the corbels have been added to the columns, like so, and it doesn't even matter for the software that those beams are at two different levels and going at different directions. It basically recognizes, okay, this column has beams here and here, I need to support those, and there's beam as well here on the lower level, let's support the beam as well. So here it is, that's for us, that's done. The reinforcement of the corbel, we'll be doing that later at the drawing stage actually. Okay, so let's go back to top view, rotate that. With that done, we can go ahead and actually start placing hollow core slabs. But before we do that, because I will be supporting my hollow core slabs on those ledges, I do not want to, my hollow core slabs to go through this. I can just click through like points wherever I want to have the area with our hollow cores, but it might be easier to do it by first creating an area that will create a cutout in our hollow cores. So let's go and utilize the draw recess filling. I just want to do that in a slab. I want that to be cut out, so it will go through the whole slab. It won't be like a recess in the slab. It will be a rectangular opening. It could be circular if we need to create a hole in a hollow core slab, because we can use this tool to also create holes in slabs and in elements in general. Yeah, and that's sufficient. What I'll do now, I'll specify that on screen. So this will be my my origin point for the rectangle, and I want to offset that. I want to create an offset of 50 millimeters of that face. So that's one, and let's create the one on the other side as well. Okay. like this. And now my recess is prepared. It's prepared, so I can now draw the elements. The depth of the support, as far as I remember, again, that's 150 mil for the ledge. So let's say we'll support that by 120 mil on both sides. Let's go with hollow cores now. So that's our hollow core definition tool, or the hollow core drawing tool. We have predefined shapes of hollow cores, so that depends on what's in the standard that's prepared. So basically sections that you can select. We also can prepare strand patterns. So for example, like 5 strands in the bottom, 2 strands in the top, or maybe 6 in the bottom only for your pre-stressed strands. Let's maybe go with 5 and 2. There's also like the specification of like if you want to apply pre-stress to those, you can make sure it's in here. You can define if you want to automatically place in lifts. So that would be by user, and you would specify a lift type, but I'm going to go by definition now. So automatically my lifts will not be placed, because maybe you have this special like crane with a hook that will attach to the sides of that. So that's good, but I'll show you in a second how to add those lifts if we need them for whatever reason, or I mean if we need them by design for in our factory, then I'll show you how to add them at a later stage, or you can add them now. End caps, in the end cap section we can go ahead and specify the end caps. By default it's the R1 defined in our standard, or L, which basically is a straight edge. That's it. But for example, let's go with with something that we have HD19U2 as an end cap, which is this nice little rounded cutout. Sorry, let's go and select that too. If you want to add more detail, like a recess or a cutout in the hollow core, then you can of course go by this preview image and add something here of your own choosing. And let us do that now. Oops, let's go back actually, and then actually specify the height at which I want that that hollow core. Okay. My math, will it be right? The height of that is 185. Okay, we might need to lower those hollow cores to sit flush on the beams. We'll do that after the fact, because we can still move the elements in the space after we're done. So let me just select that again and select the strands, and let's accept that. So I can either select a polyline. I don't have a polyline pre-drawn for this, so I'll just select points, and my points for support will be this one, this one, this one, this one, and I'll close that with a C and space on my keyboard. And now I need to specify the support length. I don't want any support on this ledge. I want this to be free edge, so that's going to be 0, and I'll accept that. Now this edge is highlighted green. Let's go and add that 120 mil support. As you can see, the line extended. Next edge, that's going to be 0 again, and 120 again on that last edge. I'll also rotate the hollow cores, and you can immediately see in the preview there will be some cut hollow cores to fit in as many non-cut hollow cores as possible. So I'll just accept that rotation, and I can specify if I want this cut element to be at this location, or just move it around to different locations, right? So you can specify that wherever you want that to be. And you can do the same for the second one. This one is now highlighted, and I can move it as well. And let's just apply that. What you can see, that the magenta rectangle here, basically it changed shape, but the hollow core elements actually recognize that cutout, it recognized that it needs some, it basically followed the shape of the cutout, and now we have a hollow core element that's cut out around that column that we have. I'm just going to now delete those because I don't need those magenta rectangles anymore. And with that, our model is almost done. Let's verify the front view of the elevation. Yep, so let's just measure the distance for that and lower those hollow cores to fit. That's delta Z is 255, so let's move all the hollow cores by 0, 0 and negative 245. Oops, okay, let's go. Okay, let's do that from the top view, it'll be easier. That's a bit of a skill issue for me here. Okay, displacement 0, 0, negative 245. Yep, and now let's verify. Yep, that's perfect. So that's perfect. That's the way I wanted that to work for this ledge columns. And now what we'll be left with is, now I just want to place a couple of pre-stressed columns, as we also have those. Those I want to be tapered columns, and those will be this type. Of course, for this particular element, I don't have reinforcement predefined. I could define that, again, going to the definition of the beams and preparing proper shapes to have that reinforcement in this. For now, I'm just going to use it as just a pre-stressed beam. My model, I want to use the elevation to be at the top of our columns, lock the elevation. This time, I want my placement to be bottom center, not as it was the case with the beams on top of the columns, the transverse ones, or rather the longitudinal ones. Now those roof girders I'll use on the bottom center. So let's do that. I'm going to do it this way. As you can see, or rather not yet, but you will be able to see in a moment. Let me place those on each frame. Yep. Like that. The offsets are still applied from what I gather from the previous placement. If you would want those offsets, you would modify that with the O command now. Okay, so, and space to accept that. Let me go to this isometric view for you. And as you can see, we have now sloped columns, sloped beams, sloped pre-stressed beams. Basically, the software automatically recognizes that it's a sloped section, and it symmetrically tries to place create the slope symmetrically along the center of the element. And of course, the element can be as long as you need it to be. Of course, there's limits in software in the standard that, for example, some element can weigh more than X amount of tons, or can it be longer than X amount of meters. So that's, of course, and logistically, some elements can be infinitely long as well. So we do have some safety precautions in the software. It will tell you if the element is too big. Basically, highlight everything red. That means no good. And yeah, that's it. So this would be about it, about the modeling of all this. Now what we need to do before we proceed with creating the drawings, we need to save those elements to the database. So we will be able to see those elements in the project manager. And so we will be able to create, so basically the elements will have their own numbers, and we actually have some elements with names not unmarked elements, so they can have drawings applied. All right, so first things first, let's save the columns to the database. So we have a tool under the columns section, that's the save column tool. I will select basically the whole model. It doesn't matter that I select like beams and slabs with this, it really doesn't matter. Now, let me press enter to select the first column mark being C1, and now columns are saved. You can see you have C1, C1, C7, C3. Basically, our columns are now saved. Let's go to beams now. I'm going to select all of them again, and now I'm asked, because there's a distinction between the non-stressed and pre-stressed beams. Let's go with non-stressed first and make those B1s as first number. So we've got B1s as the alleged beams and B2s for all the beams going along our frames. Now we need to repeat the process for the beams, because we need to also number or rather save to database the pre-stressed beams that we have for our roof. And they're saved, so pretty quick. And lastly, the hollow core slabs. This time I don't have to select anything. I can just click all from the menu. It will scan the model for slabs, and HC1, that's perfect number for our HC1 slabs. And we have a couple of hollow core slabs. So we have hollow cores 1, 2, and 3 basically. With that done, the whole model is now saved. With everything being saved, I can go ahead to Project Manager, and that's this one for my project now. And I just need to refresh, or rather update the model. So the database updates with all the elements that we've created, and like so, it loads up the elements. So those are all beams, columns, and hollow core slabs that we've created. You can see we have the ledged elements, we have the columns with corbels, we have the ledged beams as well, and we also have hollow core slabs. And as you can see, we can even see the fine detail on the edge that we've created. If we go over there, we also see the cutout around the column that we have. All right. So with this now being done, we can start creating the drawings basically. So let's go back to our AutoCAD like so, and let me go ahead and start creating drawings from columns through all the elements that we have. It's going to be very simple, couple of clicks, and it's going to be done. So I want to generate drawings for columns. So under the columns section in the ribbon, we can go ahead and generate the drawings. So I need to select all the columns like so. And now all the columns that we have are that I've selected and want drawings to be created for are shown here. I can, for example, change the template for the drawing. This is RP layout. I could change if I want. I can have multiple drawing templates for the columns. Let me cancel it out and just leave the one that I have selected. And it's just a matter of clicking OK and waiting for the program to do its job. So create those drawings automatically for us without much hassle. It's going to take a minute or two for this many drawings to come up. So we just have to bear with the program a bit. Of course, the more elements you select at the same time, the longer it might take, but still, this is 7 different beam types and the drawings are already done. Let's do the same for beams now. Let's go to the non-stressed ones. And as you can see, we only actually, even though we have multiple beams in the model, we only need 2 drawings for the non-stressed ones, because we only have 2 types of those elements. So let's do that. And that will be quicker, as you can see, than the columns, because there's just, 2 drawings. Still things a bit, but that's fine. And it's done. So same for the stress beams now. Let's do that. And let's accept that. Oh, no drawing template specified. That's because I don't have the template for pre-stressed beams, but we can maybe select one. And let's do that. Done. The drawing is done. Now I would like to create drawings for the hollow cores, but first let's show you how to add those lifts that I didn't show you before. So I can go ahead and select objects. So for example, let's add lifts those elements, and just those three hollow cores, just to demonstrate that we can do that. And yeah, I can specify the type for this particular hollow core. For lift type, I only have this one specified. It shows you a little preview that lifts will actually go into the cores as well. You can specify if you want to have the core fillings visible on the drawings, and how long is the core filling for the lifts, and if you want it to be dimensioned on the drawing as well. All right, so let's do that. Let me accept that, and you can see that those hollow cores are changed now. They're yellow. That's because we've added lifts to them. You can see they've been added here. So let me save those 2 hollow cores. Just selection, select this one, and accept that. And I don't want to use existing mark, because if I did that, then it would update all the other HC ones to also have lifts. But maybe I want to do that, so maybe I should have clicked yes. But let's just go with this, and let's not use an existing mark as well. So those are now HC4s. They're saved to the database, and if you go back to the project manager, and if I update that, yep, you can see immediately that the numbers on those hollow cores were updated. Right, so those are our HC4 hollow cores. Okay, with that done, go back to the drawings. Yep. Well, let's maybe select this column to see the drawing, and let's open the column drawing. That's a C1 column, so let's select this one. So I am getting a preview of the drawing. What do I get in the drawing? That depends on the template that I have. Maybe I just want like one view. In this particular case, if we go to the drawing, the layout, we get the B sections for some reason doubled. Might be some issue with the standard. Let's check another column. Let's select this one maybe. Yeah, C2. Yeah. Okay, this one got 1 for some reason. So there was some duplication of the section there. Of course, curse of the live demo. Yeah. So what we get on this drawing is just one view, like with the reinforcement, a view with the dimension lines for the geometry, and another view as well as like small sections with dimensions. Now, if we go back to the layout, not the layout, but the model, we can add the Corbel reinforcement as well to this drawing. So let's do that. There's a tool for that. We'll just select the Corbel. It will automatically recognize that, hey, that's a Corbel. It gives me a small little preview of the reinforcement that's in the area, so to speak, for this. And I can decide whether I want the main reinforcement of the Corbel and what type of reinforcement I want. So in the preview, you can see the bars that are going to be applied there. You can specify the dimension of those bars as well. So say it can be bar size 12, maybe 16 will be more reasonable for this type. And then the other type of reinforcement you can have, like horizontal bars, other different types of reinforcement. There are other types of that we have predefined in here. Let's maybe skip this one, but for the secondary reinforcement, let's go ahead and add some horizontal bars. We can change the spacing on that. I can, of course, well, not of course, I can, for example, rotate that view as well, so I have more clarity on what's happening. So let's change that to maybe 55 on the first dimension. Right, that moves down, and let's maybe go 65. Oops, 55. Let's go 65 and 65. Yep, that looks better. That looks better to me. So we can leave it like this. And for the other, like reinforcement, of course, there's multiple ways you can add that Corbel reinforcement. As you can see right now, there's really a bunch of reinforcement. Like if we want like stirrups going this way, and sure, you can do that as well. So multiple different ways of adding the reinforcement. Let's go with those 51 shapes. And if need be, we can also add some dowel reinforcement just to demonstrate that. So that's a bar like this. If we didn't have a lift here or a connector here, then we could add this to maybe add a hole to the beam for connection. That's a thing that I forgot to demonstrate. We can go back to that in a second. We'll refresh the drawings anyway. All right, so let's forego this and let's accept that. So reinforcement has been added to this particular element, but I'm also asked if I want to add this type of reinforcement to the other corbels and the remaining elements in the project. I can click yes. I can do this like so and accept that. And I can replace any existing Corbel reinforcement that's in the model if it was there. That's how we can add reinforcement to our drawing. We get the dimensions for it, we get the specification for that. I can refresh the drawing now. Under the MTO section, I can refresh the drawing, and with that, the drawing will be regenerated. And once it's regenerated, I'll get the updated schedule of reinforcement, like so. So basically all the bar shapes that were created for me in this are now shown here with the dimensions of the legs and whatnot. So yeah, that's how we can create this reinforcement. I can save that drawing right now. So just a second or two for it to save. It's going to be nicely available in the database. And that's saved. Let's go to the floor plan. One thing that I, fortunately in the rush and all the emotions, forgot to demonstrate, I want to, for example, create an opening for this lift, so I could possibly connect those elements. So how to do that? Easy, really. Let me select that. This is B2, so once I edit this, all will be edited as well. I need to go to ends, and I will need to create a circular opening at the end, and it's a matter of specifying the diameter. So let me measure first, so it will be easier. Dimension, let's measure that. So 170 mil from the edge to the center of the opening. And I also want to know the diameter that I want to have, 22.5. So 55 for the 55 millimeter opening should be good. So let's do that. Properties, like so, ends, circular, as we measured, 170 this side and 55 here, and let's copy that to the other side. Let's add that. Let's update the lifts. As you can see, the element is modified. It's now yellow, and I can exit and save. I can use the existing element mark like that, and if we zoom in, all the other elements, because I changed just this one, or they're B2 and use the existing mark, then the elements have been saved. And since they've been saved, then they've been updated in the database, and all of them have now the applied opening to the for the lift or connecting element. So we can go back to the model. We can refresh that. Once it refreshes, I'll just zoom in on that spot. Yeah, there it is. There it is, ready for joining of the elements. Of course, we can go back to the AutoCAD, and we can refresh the drawings for the beams. So let's select this one, and since the drawing was created without that opening, we need to refresh the drawing and reinforcement and whatnot. It will be quickly done. It's just one drawing for all those elements, so it will be quickly done for us. Once it's done, just a matter of opening that drawing and verifying that everything's okay. And there you go, there's the opening. There it is, added, visible, and the opening. If we go to the drawing, we have a section view, we have a view of the reinforcement and the dimensions of the elements, as well as like the dimensions of the element from the top view. Okay, so I would guess that would be everything for this webinar. Go ahead, if you have any questions, post them in the chat or email them directly to me. I'll be sure to get back to you on that. And with that, let me just go ahead and share a couple of useful links for you. So either our LinkedIn, that's Tuso the Official, our YouTube channel, or the official website. Go ahead, have a look at all the info that we have there. And again, thank you very much for your attention, and I'll see you in the next webinar. And we will focus on walls then. Sandwich walls, sandwich panels, solid walls, all that fun stuff. I'll be filling in the gaps between columns, creating some additional structures. So that will be interesting. Show you all about it, and yeah, see you next time.